Imagine a world where the mighty woolly mammoth roams the earth once again. Thanks to groundbreaking advancements in genetic engineering, this dream is closer to reality than ever before. But how do you bring back a creature that's been extinct for over 4,000 years? Let's dive into the fascinating science of de-extinction.
Professor Roy Weber of Aarhus University, Denmark, is an expert on mammoth biology. This is his last chance to find more of the strange liquid that astounded the world when the mammoth was discovered. If it is liquid blood, that would mean Roy could explore the mammoth's great evolutionary advantage: cold-resistant hemoglobin. Hemoglobin carries oxygen through the bloodstream. In humans, blood has to stay at a nearly constant temperature, even as it travels to the extremities. In mammoths, hemoglobin evolved to work at near freezing temperatures. This enabled them to survive harsh conditions with oxygen-rich blood flowing to their icy cold feet. Roy hopes that the liquid found near the body is indeed blood, and that there will be a lot more of it inside the carcass.
The ultimate aim for me as a physiologist is to find specifically how the hemoglobin is adapted to the environment in which the animals live. And that temperature shift is very important to see how the blood can cope with dealing with a big difference in temperature and still function.
The trouble is, the mammoth seems to have run dry. They try again, probing the lowest parts of the mammoth's body, like the elbow.
Wow! It's better than I hoped.
Yeah.
Look at that. It's brownish, it's oxidized, but it seems to be real blood. I mean, looks wonderful.
Oh my God. You need, quickly. You need a bigger syringe. It's really exciting because with that amount of material, you can do all the analyses that you need to do to understand what that fluid is and what it contains.
The woolly mammoth, an icon of the Ice Age, was a massive elephant-like creature adapted to survive in freezing climates. Its extinction left a void in the Arctic ecosystem, but now scientists are working to bring it back, not just for nostalgia, but to help restore balance to the environment. At the heart of this mission is cutting-edge genetic technology. Scientists have collected DNA from preserved mammoth remains and compared it to their closest living relatives, the Asian elephants. By identifying key genes responsible for traits like thick fur and cold tolerance, they can edit these traits into elephant DNA. The process begins with editing elephant stem cells to express mammoth traits. These cells are then used to create embryos, which are implanted into a surrogate elephant. After a 22-month gestation period, a hybrid mammoth elephant could be born, a living, breathing step toward de-extinction. If successful, the return of the woolly mammoth could help combat climate change by restoring Arctic grasslands and reducing greenhouse gas emissions. This project is not just about bringing back an extinct species. It's about shaping the future of our planet.
先ほどの筋肉の位置をもう一度確かめてみよう。そうそうそうそう。
Back in Tokyo, Dr. Naoki Suzuki oversees the assembly of high-resolution images from Liuba's CT scan. Images that will tell her tale from the inside out.
できたら確かめてみよう。
Awaiting those results Dan Fisher takes time to consider Lyuba from another angle.
A sort of attempt to make some connection with the phenomena that we're studying.
Dan lets his mind drift back to the Siberian steppe 40,000 years ago. Baby Lyuba might have been only a few months old, traveling with the mammoth herd, under the watchful eye of her mother. She would mimic the gestures of her family, but would not yet be coordinated or mature enough for a diet of plants. Lyuba would still be dependent on her mother's milk. Today, baby Lyuba's extraordinary preservation could lead to new discoveries about mammoth behavior. And Dan hopes she's ready to share her Ice Age secrets. Secrets he'll pursue here and in the field when he follows her trail back to the tundra.
The journey to resurrect the woolly mammoth is a testament to human ingenuity and our desire to right the wrongs of the past. As science pushes the boundaries of what's possible, we stand on the brink of a new era, where extinction may no longer be forever.
After months of delay caused by Russian customs, the tissue samples from the mammoth finally arrive in South Korea.
When I looked at them under the microscope, I first had very high expectations that this would actually give us something that's never been found before.
In-sung wants to find surviving cells with their nuclei intact.
It's actually looking quite promising. I think we can actually extract some of the DNA out of the sample because it seems like there's presence of nuclei in the samples.
But in case they don't find it, there's always George Church's Plan B. And even though it is only happening in the test tube, he has already made the first step on his journey to bringing back the mammoth.
We've introduced now a few mutations that are relevant to adaptation to cold climate of blood.
What happened during her last hours on